Hello and welcome to session 9. So today we're looking at non-right angled trigonometry. Let me just get my iPad going. I think there we go. All right, please let me know if you can see my screen, just to check. Should be able to see it now. Just give it 2 seconds. Amazing, thank you. All right, so this is quite a nice topic. If you have this question, which you most likely will in your exams, it's great because it's just formulas. Everything comes down to the formula. Once you have the formulas, you fill in what you know, what you're given in the question, and then it becomes quite obvious what you need to figure out. Sometimes they're going to loop in some trigonometric identities within the equation, or little bits of other topics. But essentially, once you get down to it, it's just these formulas. And we'll have a look at some different ways that they might ask it in the exam questions in a little bit. So we'll just go over to start with a little refresher on sine, cosine rule and area of a triangle rule. Area of a triangle is using sine, so it's not the usual area of a triangle rule, which is just base times height. But if you're given different information, if you're given 2 sides and an included angle, then we're using this area of a triangle rule. So it's quite common that you will have sine rule and then area of a triangle, or cosine rule and then area of a triangle, or identities and area of a triangle. We'll have a look at that. And so yeah, this is what you have in your formula booklet. As usual, I recommend that when you have a question on this topic, that you open to the page that this is on. So you have these formulas right in front of you, and make sure when you copy them down correctly. So when you get to a question and you read it, you decide, am I going to use a sine rule? Am I going to use cosine rule? Whichever one, go and immediately write it down. Write down just the formula. Don't even substitute anything. Don't change it in any way. Just at the top of the question, write down the formula. Often you get a mark just for recognizing which of the rules to use. If you've recognized that you need sine rule or recognized that you need cosine rule, just by writing that formula, you show that you recognize that. So it's also a good idea to make sure that you haven't written it down wrong, because if you've written it down wrong, everything is wrong. So be careful of that. And then also, once you have it on the page, it's easier to substitute just directly from the formula. So let's get into it. So to start with, we've just got to talk about how we set up these triangles. So if we have a triangle and we're using cosine, sine, or area of a triangle rule, it's because it's not right angled. So if it's a right angled triangle, always use SOHCAHTOA. Just does not make any sense to complicate yourself with these sine, cosine rules if it's right angled. But if it's not right angled, then you're using these. And it goes with the standard to follow the formula. That would be angle A, angle B, and angle C. So for angles, we use capital letters in the formula. And then whichever side is opposite angle A is the side A. And for these, we use little letters. So you can see that these are corresponding to each other. So opposite B is going to be our little B side, and opposite C is going to be our little C side. So this is really important that you have this set up correctly. And sometimes the questions might use A, B, and C, but in a different way to the formula. So in a different color, please take a different color pen into your exam. Just go on your question and use your own A, B, C, so that when you are using the formulas, you're doing it correctly. And not getting confused with their A, which might be a different side or different letters. It just helps you to know, and do it in a different color so that you can see it's the label you're giving to the triangle. So once we have it labeled, it's quite easy to just substitute and plug into the triangle. A note for the sine rule, we have A over sine A. We have all three. But when we're working with it, we don't need to use all three. Generally, we just need 2, like that. You need a a side and its corresponding angle, and then either one of these to figure out the missing thing. So you need 3 pieces of information to figure out a missing one. You don't need all 6 here. You never need to use all 6, just 4. So when we know 3 pieces of information, we can figure out the 4th. Also a note when you're using the sign rule, if you need to figure out a side, a missing side, you want to use the formula like this: A over sine A equals B over sine B. But if you're asked to find an angle, you can flip it on its head, and it's way easier to work with and to work out. So sine A over A equals sine B over B. So you can work out an angle like this, but it just has a few more steps, and we want to have as few steps as possible to avoid making mistakes or time-wise. So when you're finding an angle, flip it. So whatever you want to find is what you have on top. So that's just a hint about the sine rule. Cosine rule, if you can see, there's 2 formulas there. This one has C. Let me just put that up in case you can't see it because of my video. Let's do it like that. So for the cosine rule, zoom in, zoom in, zoom in. This one with C squared, that's when you want to find a side. And this is the same formula, just with the angle first. So this is in terms of the side that you want to find. This is in terms of the angle you want to find. So they're exactly the same formula. You can use either one, but it's way easier to find a side using this one and an angle using this one. Just takes out missing steps. One thing that I see super often as an examiner is people forgetting that it's C squared on the side. So they go and they solve and they do everything and they get an answer and they leave it like that. But remember, this is C squared. So the last step that you have to do is to square root your answer in order to get rid of that squared. So that often happens. Or this, having cos C, it's not finished on this side. So they do all that and they get a number and then they leave it. But you have to cos minus 1 this, or cos, whatever that was. That's the final step. So that is another reason why it's super important to write your formulas above, so that you keep going with that and you don't forget at the end and you don't get lost calculating this, that you forget the last step. And for the area of the triangle rule and cosine rule, they only work with what we call the included angle. So if I'm using the cosine rule or the sine rule, let's say I have this side, and the angle I'm working with, it has to be this one, the one that's included in the middle of those 2. So it only works like that. So I can't have this side and use the cosine rule or area of a triangle rule to find this side or this side. So they always have to be like in that little corner together, and we call that an included angle. It's included between the 2, included angle. So for cosine area of a triangle, make sure that it's always that included one. They might say you're given A, you're given B, and you're given angle A and angle B, and you would need to use that all the angles in a triangle add up to 180 degrees to work out the missing one. So sometimes they're a bit sneaky about that, but you just need to remember it only works with the included angle. Or we could have B and C, then A becomes the included angle. Or, I need another color, let's not get confused. This is purple. Yeah, B, we need C and A, that's the included angle. So that drawing looks a little bit crazy now, but hopefully that makes sense. So let's go and try an example. All right, so we need to calculate the length of BC. That's this one over here. There's B, there's C. So we need BC, that one. I'm going to call it X. Oh, these allergies are going crazy at the moment, the hay fever. So here we're given this side and this side and this angle. So can you see that's an included angle over there? So we're all good. If we have the included angle, these 2 sides, we can find the opposite side, the corresponding one. So like I said, let's take my own advice. We need to go and label this triangle. So this is angle A already. So I'll just keep that as angle A. So that means this is side A. This is angle C. So this means that's side C. And this is angle B. So this means this is B. Just takes out all the guesswork and thinking work when we're substituting into our formula. So because we have an included angle on two sides and we're trying to find the opposite side, that means we need to use the cosine rule. The sine rule would need to have a corresponding angle with a side, but we don't know the angles here. So if we only have one angle, then it's cos. All right, let's write out the formula. So c squared equals a squared plus b squared minus 2ab cos c. So how they've given us this formula is if we're trying to find c squared, but we're trying to find a squared, or a, side A, that's what we've called it. But this formula works anyway. It can also be a squared equals, and now we use the other two, c squared plus b squared minus 2cb cos a. See how I've just switched the a and the c? That's the one we want to find. We could also write it b squared equals a squared plus c squared minus 2ac cos b. These are all the same formula, so it just depends on which one you're trying to find. So I'm going to use this one, the a squared, because I've called that a. And if you wanted to use c squared, you could just call that one c, but they've already called that angle a. So I'm going to use that one. Let me just get rid of these. Great, so we have our formula ready to go, ready to plug in. So I've called this my side x, so x squared. And now c squared is just 4.8 squared plus b is 6.4 squared minus 2. And then that 4.8 times 6.4 again. And cos of my angle A, which is 123 degrees. So we're in degrees. Good to check the calculator. Let me look at my calculator. Yeah, I'm in degrees. All good for when I calculate. Now, depending on the question, if you're in paper 1 or paper 2, if you're in AA, you might need to simplify this on your own, but then they'd give you nicer numbers, not these decimal numbers. Let's assume we're in a paper 2. This entire thing we can put on our calculator, and that's really going to help us to not make mistakes. So 4.8 squared, let's go, whoops, 4.8 and 6.4 squared. Use brackets around your numbers. It's another thing that I see so many times, that people don't use brackets nearly enough and get confused. 6.4 cos 1, 2, 3. Trig cos 1, 2, 3. And I'm in degrees, so all is good. I've got all my brackets. There we go. 97.5 to 3 significant figures. 97.5. Oh, but I'm not finished, so I'm actually going to take the whole thing. 97.46 something. I'm not at the end, so I can finally square root. And actually, I could have just gone here and done a square root over the whole thing. So let's take, and I want my answer, 9.87. And my unit was centimeters. Oops. Centimeters. Okay, so there we have it. To 3 significant figures, we found AB. And maybe I should, or just, BC. BC. In case we needed to use it later, it might be good to write it in terms of BC. And especially, this question isn't continuing, but if it is, again, highly recommend, as soon as you've calculated something, let's Just go and write it in there. Move that to the side a little bit. As soon as you've calculated something on your diagram, go and fill it in on your diagram. It can really help to show you things that are missing that you might need later. So as soon as you calculate it, fill it in. All right, there we go. That's the cosine rule. Which out of centimeters. All right, another one. So we have been given some information here. All of the information that's there is already on our diagram, but sometimes in your exam it won't be. Sometimes they'll put some information in the question and you need to go and fill it in. So when you're going through it, just double check that they have put everything on the diagram, and if it's not there, for you to add it yourself. Ooh, and one really big thing that I also see quite often is a triangle that maybe looks like something like this, and people assuming that it's right angled just because it looks like it's right angled. But if there is no sign like this, then you just cannot assume that it's right angled, and it probably isn't. And I think maybe sometimes they do that on purpose. So if there's no right angle symbol over there, 90-degree symbol, do not assume that it is just because it looks like it is. So you can't assume any of those things. Similarly with cutting angles in half, when sometimes like here, if I cut it in half, sure, I can assume that it's 90 degrees, but sometimes they might put the angle a little bit like, let's say like this, for example, and that looks like it's cut in half. So you might think, oh, 90 degrees. But if they don't say it, it's not. So just be very careful with that. That was a little side quest. Okay, so let's see. Let's label our triangle. What have we been given here? So I have my angle B there. So this is side B. Angle A. So this is side A. Angle C. So I've been given side C. So what two pieces of information are linked? So I have an angle A and a side A. Okay, so that's already one piece of information. We like to have those. I don't have an included angle side. So here I have an angle and there I have a side, but there's no side here. So it's not cos rule because I don't have the included angle with my two sides. So it's going to be cos. There's my piece of information. Here's my angle. And what I could use with this information, these two, is to find this one. And let's see, is that what the question's asking? Yeah, AB. They want us to find AB, which I'm going to call X for now. So when I have those two pieces of linked information, we have three of them and one to find. We know it's sine rule. So let me write out my formula. We're working with sine. We need to find a side. So I'm going to write A over sine B. No substituting yet, just formulas. And we're not actually with B because I've called this C. So C over sine C. There we go. So now I can fill in my information after I've double checked that I've written my angles correctly, my formulas correctly. So A was 10.2 over sine A, sine of 134, 134. And C we called X over sine of 28. So everything is filled in, so we get a mark for substitution, and now we can solve. So what I need to do is I need to find X. That means I need to put that sine 28 on the other side. So I'm going to write sine 28. Remember to show all steps. You want to get all of those method marks. Especially if you write something wrong or calculate something wrong and your final answer is wrong, you want to be able to have all of those method points equals X. Now this whole thing I can put on my calculator, but if you did that separately, make sure you don't round just yet. So sine 28 times 10.2 close my brackets times 10.2. Oop, got an extra divide. divided by sine 134. And seeing as we're timesing and dividing, my order of operations is not important. I can times these two and then divide, it doesn't matter. All right, so we get 6.66. 6.66, yeah. X equals 6.66. And we're working in centimeters again. Did I read that correctly? Yeah. All right, there we go. That would be the answer, 3 significant figures. That is sine rule. If we were doing an angle, we would just have to do the extra step of finding the sine minus 1 of that angle, also called arc sine, the inverse operation. So don't forget that. Make sure you've really showed you're working and go step by step. Don't go too fast in your exam as well. Really take your time to think it out. When you rush, you make mistakes. But in our exam strategy session, we'll talk about timing and things like that. So far, so good. Any questions? Okay, so, here we have an angle question. That's good to practice. So again, let's label my triangle. I'm going to go with my classic A, B, C. I don't like E, F, D. I want to keep with my thing. So then I have that side A and side B and side C. What have I been given? I've been given a corresponding angle and side here. And I've been given a corresponding side. I need to find the angle there. So this is sine rule. So we need to find angle A. So instead of putting it this way, I'm going to put my angles on top. So I'm going to have sine A, angle on top, over A equals, and my B, sine B over B. So we have sine of X. Oops, sorry. It's my dog. It's okay. We're training him with people outside at the moment. He's a little bit protective, so apologies for the sound. He's a very loud dog. Hi. Everything's okay. Come. All right, so we have 6.7, 6.7, and sine B is sine 97 over 8.1. All right, I got distracted, so if I've made a mistake here, just let me know, but I think so far so good. Great. All right, so again, I can take my 6.7 and multiply it on the other side to leave sine X on its own, 97 over 8.1 times 6.7. And to get that on its own, that X, I'm going to have to sine minus 1 of sine 97 over 8.1 times 6.7. And let's put that all on my calculator. So are we ready? Let's go sine minus 1. Where is my fraction blocks? But no, it's fine. I'll just do brackets. Sine 97, sorry. Just have a closed bracket there. Don't want to get anything wrong with my algebra here. Divided by 88.1 and not times there. I just want this to be together, so I'm going to put an extra set of brackets there. Whoop, there we go. And now times my 6.7 and close bracket. And now I think we have enough brackets. We are good. There we go. 55.2. And I can round because I'm at the end. 55.2. what were we in? Centimeters. And done. Well, they say give your answer to 1 decimal place. In your exam, it will be 3 significant figures, but sometimes they do actually give you a different direction. So they say give your answers exact or to 3 significant figures unless stated otherwise. So maybe the question will state otherwise, so 1 decimal place. So important to read that, and when you're reading a question, highlight that because it's so easy to forget. So let's say, well, that is 1 decimal place, so we're all good. But make sure that you check that out. Okay, this is a typical kind of question that they love to ask with the cosine rule is calculate the size of the largest angle. So they've given us a triangle and they've said we have 4, 6, and 8. See, they've not given us any angles. And they want us to calculate the size of the largest angle, or they might say smallest angle. So largest angle is always the one that is opposite the largest side. So they're just assuming you know that. They're not going to say that, but they're going to assume you know that. So don't go and calculate all 3 angles. Just pick the one opposite the largest side. So smallest angle is opposite the smallest side. It's a useful tip there. So let's label this triangle. This is going to be, I'm going to call this C, C, and A, B. So this is B. I probably made this way too confusing with all the different colors. Let's put them in a different color. Okay, so I know now 8 is my largest side, so I want to know angle C. The one opposite is going to be my largest angle. So let's put that on our diagram, and we need, let's go in blue. So now we are going to be using this because we want to find the angle. We need cos C. So we're going to use this part of the formula. Cos C, let's write it here, equals A squared plus B squared minus C squared over 2AB. So this is just the cos formula rearranged. It's not in terms of C, but in terms of cos C. And let me just double check one more time that that is indeed correct, and it is. It's very important here that this is positive and this is negative when this is the matching angle that we need to find. So if that is the one, then this needs to be the one being minus words. So this I often also see as a mistake, is people getting this order wrong. So very important that we're going with our correct formulas and labeling correctly. So what do we have? Indeed, we have the largest side 8, so we're finding the opposite side C, so that's all good. So cos C, what we're trying to find, A squared. Now, our A and B in this, the order doesn't matter for them because we're just adding them and multiplying them. So when you add and multiply something, the order doesn't matter, but when you subtract something, it does. So our order of A and B doesn't matter. So we have 4 squared plus 6 squared minus 8 squared all over 4 times 6. And that gives us 16 plus 36 minus 64 all over, that is 24 times 2, so 48. So 16 plus 36 gives us 52. Oops, sorry, cos C. I was going to cos -1 at there, but I didn't, so keep writing that. So let's put that in on a calculator. What did I want? Yeah, let's go and do the whole thing all together. cos minus 1 of... So we need cos minus 1 of 52, I said, minus 64. Put another bracket there because we need to subtract first. Divided by 48. Was that all we needed? Yes. And we get 104.5. Seeing as it's the end of our question, let's already do 3 significant values. So 104. Degrees. There we go. So the largest angle, and that is quite a large angle, opposite our side C is 104. So go and write it in. Oh, sorry, that's a little bit off my screen. There we go. Okay, let's get into some exam style questions. Now, this is a question where they have asked us to find the area of the triangle ABC, but the first question is something to do with identities. So they've given us that this is 6 and this is 8, and they've not given us an angle, but they have given us that cos of, let me highlight it, cos of A equals 5/6. But we're going to use the area of a triangle rule later, which is in terms of sine. So we need sine to help us. Also to note that this is a paper 1. So we don't have a calculator. So we can't figure out what angle A is actually. This is not one of our special angles. So if I want to do cos minus 1 of 5/6 without a calculator, I don't know about you, but I don't know that. And you're actually not expected to know that. In this question, you're not going to find out what that is. So what they do want is sine A. Another thing that I see people getting confused with is they think they need A, but actually they need sine A. So how can I relate cos A and sine A? If I've been given cos A, think of it like a formula, and I need to find out what's missing. So this goes to our identities. So I have the identities here that we've been given. Again, that's in front of the text box. So let's see, can you see that? There we go. They've given us these identities. So if I know cos A, cos of theta, which of these could I use? Well, this one has cos theta, but then I need sine 2 theta. I need a few things for this. Here, sine squared theta, cos squared theta. Well, I have cos theta, not squared, but cos theta. And that has sine theta in it as well. So if I can input this, I can figure out this. It's just like one variable that I don't know. None of these would work because they're for the double angle identity. So they're not going to help us. So we need the Pythagorean identity. So let's write that Pythagorean identity in, let's do it in green. Green seems to be my chosen color for formulas today. Cos squared theta plus sine squared theta equals 1. And just a reminder that what this is saying is it's cos theta squared. We just put the squared there. But it can often look confusing because you might think, oh, I don't have that. But we have cos theta, and then you just square it. So I'll write it like that. All right, so cos of A is 5/6. So my cos theta, I can write this cos A if you want as well, just to make it really clear. Sine A squared equals 1. So I have this. That's 5/6. 5/6 squared. Plus, and we're trying to find this, sine A, maybe I'll keep writing it like this, equals 1. And now I'm just solving for sine A because that's what I need to find. So I need to make this the subject of the equation. So I'm going to write sine A squared, and I'm going to take this across to the other side. So that'll be 1 minus, and multiply it out while I'm at it. 25 over 36. 1 minus 25 over 36, well, if I take that, if I eat 25 pieces of my pie and I have 36 pieces, I've eaten 5 plus 6, I've eaten 11 pieces. So sine A squared equals 11 over 36. And now, finally, to get sine A on its own, I've got to square root the other side. So square root 11 over 36. And can I simplify that? Root 11, I can't simplify. It's just root 11. But 36, I can. That's fine. I get root, if I have root 36, I get 6. Just a reminder that you can split a root like this and then solve them and simplify them accordingly. Okay, so now we found our sine A. That was just the first part of the question. And given that they had asked us to find sine A, we're probably going to need that for the area of our triangle. And remember, this is a non-calculated paper. So this is still applicable if you're in AI/SL and you always have your calculator. Similar sort of thing, you'll just be able to use it. But the methods are the same. So sorry, that was question A. Now question B, find the area of triangle ABC. So we've got sine A is root 11 over 6. So here, our angle, the angle we're not sure, but let's just write sine for now. And we need, let's write out the formula, half AB sine C, which can also be, that's A for area, by the way. I should actually, let me write area because I don't want to confuse us with it being A, like angle A, area. And we have AB sine C. So again, that included angle. I can't do AB sine B. It has to be the ones that are including it. So I have 6, 8, and my angle included. So, oh, no, that was just 11 over 6. So we can write half. A was, I've already forgot my numbers, 6 and 8. 6, 8. Sine C, or sine A in this case, is root 11 over 6. So see, that's useful. That's where we found it. Why we found it. And because we don't have a calculator, we don't need to figure out what sine of our angle is because we have the whole thing. The whole sine C is this guy. So I'm just not going to put that there to confuse anyone. So now we can simplify. Well, I have 6 and 6 over there. I'm just going to cancel out. Half of 8 is 4. So 4 root 11 is what we're left with. And there we go. That's the area of our triangle. That was a lovely 5-mark question. So they love to do that, include a little bit of identities with the area of the triangle. Anytime that they give you cos of A, sine of A, where they give you that angle, this is always a massive hint that you're going to have to use one of the identities. Instead of just saying an angle is, I don't know, 96 degrees, they say cos of an angle is something like a fraction or some sort of radians. Then, well, no, it won't be radians, but something like that is your hint that you're going to need to use one of these formulas. I'm just going to take that away so it doesn't confuse anyone who's watching later. In our mark scheme, see here how you have a valid approach using Pythagorean identity. So it's not even any correct answers yet. It's just a valid approach. Then substituting into it, so really showing those steps, and then the final answer there. That was a lovely 3 marks. And here, nothing crazy, just substituting into the formula and the final area. So please don't forget to show your substitution. Another thing that I see students doing a lot is just writing the formula, A equals half AB sine C, putting it all in on their calculator, and then just writing 4 root 11, which does not get you marks. You should show the formula, and then you should show your substitution. Do not skip that step. I'm going to put a cross through this. No. So show substitution. Really important. Always show your substitutions. Let's try another one. All right, we have a triangle where you can immediately see, hopefully, in fact, I'm not going to say, which rule are we going to use for this? Are we using sine rule or cosine rule? What do you think? Cosine or sine rule? I haven't asked a question in the chat yet, so. Thank you. Nice. We're using cosine rule because we have an included angle here. We have two sides, 2 and 3, and an included angle over there. That is our hint for cosine rule. We're needing to find this one. So I'm going to call this side C just because my formula is already with a C for the side we're trying to find. And call that A, B, that'll be angle C. See, it's got R and Q, but that can sometimes confuse you. So really recommend that you relabel it yourself according to the formulas. Saves a lot of guesswork. So we need to find PQ. Classic sine cosine rule question. Write our formula. 2AB cos C, and let's start filling it in. So C squared, we don't know what that is. A squared is 2 squared. B squared is 3 squared. 2, 3, cos C is 60 degrees. Cos of 60 degrees, do you know what that is? That's one of our special angles. This is also a paper 1 paper for our AA people, AA paper 1. Nice to note. That means you need to know what cos of 60 is without your calculator. We had another session on this if you want to go back and check on trigonometric equations and identities. So tips for knowing those, go back and watch that that video, but this you need to be able to know. This is for AA, not for AI. If you have AI, like AI, the course, then you can use your calculator. Cos of 60 is a half. Just a quick one, sine of 30 is also a half. So they switch. Sine of 30 is a half, sine of 60 is a half. So that will be nice for us. Let's go and carry on with that. So we have 4 plus 9 minus. This is going to be a half. So 2 times a half is just going to cancel out. So that will be 6 altogether. Maybe I will just highlight that so that it's clear to anyone who's looking at the notes later. And 2 times 3 is 6, 2 and 2, perfect. C squared equals, so 4 plus 9 gives us 13 minus 6 gives us 7. So don't forget to square root one time, it gives us the square root of 7. And we don't need positive and negative because it's a length. So it's just root 7. You can show, and usually you're encouraged to do this, that it's plus minus root 7. And then you say it's a distance, so it can't be negative. They often give marks for that. All right, so C is root 7. Again, when you know it, fill it in. Now consider a general triangle where we have no values, but some algebraic expressions. Do not panic. Just interpret it as a side. Keep going with your formula. All you need is your formula. So we're still using the cos. Where shall I do it? Shall I do it underneath or across? Let's do it across. So we're still using cosine. So let's label it. We have, well, now we have A, B, C. So side C, side A, and side B. Great, and A, B, C, all good there. We have our included angle. It's the same kind of triangle. We're going to have cos of 60 again, which is a half. So we now want to show that AB, this side, is equal to that. Remembering again that we can't use this in our question. We have to end up with an answer that looks like that. So let's fill in what we know, but as usual, start with the formula. C squared equals A squared plus B squared minus 2AB cos C. And yeah, let's fill in what we know. I'm going to call, should we call this AB? Why not? Remember our mission. Now, A squared, well, that's 3x minus 1. Just trust the formula. Keep going. Don't be put off by these squareds and algebraic expressions. B squared, x plus 2, all squared, minus 2a was 3x minus 1. It's looking horrible, but we're going to simplify and it's going to be okay. Trust the process. Even if you are unsure of how to multiply this out, or if you don't have time, or if you just can't be bothered in your exam, at least substitute into the formula. And the nice thing is that it's a show that question. So if you just substitute into the formula, you can get at least 2 marks out of 5. And if you don't have time or you can't do it, or you can't make it look like that, that's okay, because you can use what you have here to get this possibly. Maybe not in this question, I'm not sure, but in general, given that questions, show that questions, you can use that thing. So it's almost the IB's really nice way of helping you out. Like, it's okay if you didn't get that answer, but here it is to help you going forward, which is quite nice. Anyway, cos C, which I'm just going to immediately put as a half over here, because we know that that is cos of 60, which is a half. Time for some multiplication. I already see that that 2 and that 2 there can cancel, that half, so that saves a little bit. Okay. Let's go for it. Multiplying out. When we multiply out, we get 3x times 3x is 9x squared minus 6x plus 1. If you catch any mistakes here, let me know. I'll put that as your job to be spotting me. That will be 2x plus 4x plus 4. Oh my goodness. Now, 3x times x is 3x squared, and that's minus 3x squared. With this negative out here, we just don't want to get caught with that. Now, we're going to do 6x minus x, so that's, was that positive? Oh, there's a lot going on. Yeah. 6x minus x is 5x and minus 5x. Can we fit it in? And then finally, a minus 2 with a minus makes a positive 2. Well, the nice thing about this is if I have made any mistakes here, I'll be able to see that because it's not going to look like that. So I have 9x squared minus 3x squared gives me 6x squared plus x squared. So that's a 7x squared. Good. That's that one there. Minus 6 plus 4x gives me minus 2x, and there's a minus 5x, so that gives me minus 7x. Ooh, nice. And hopefully, let's see, 1, 5, 7. There we go, plus 7. And remember, this was AB squared. So now, final step, AB equals, and we're going to root this whole thing. 7x squared minus 7x plus 7. There we go. That was quite a nice 5 marks. That's very generous, actually, just for, I mean, there's a lot of algebra going on in there, but that is quite a nice amount of marks for that. So now we've shown that. Given that AB equals 7, so AB, this part over here, draw it in, equals 7. You can put that in there. Find the value of x. So instead of AB, I'm going to write 7. This is question B, and this is question C. Well, we know that AB equals that. So now we have to find x. So 7x squared minus 7x plus 7. Okay, we're going to get a quadratic here. The first thing I want to do is remove that root and put it on that side, because things I can't do much when I have a root there. So I'm going to put it on the other side by squaring. And so that gives me 49 equals this. Now, this is very sevens heavy, so I'm going to divide everything through by 7. Just to make it a little bit nicer and easier for factorizing. So I've just divided every single term by 7. Don't forget, if you divide by 7 to these, you also do this one. Then I need to move the 7 over to that side, so that because I have a quadratic, it needs to be equal to 0. So 0 equals x squared minus x. Positive 1 minus that 7 gives me minus 6. All right, let's factorize this if I can. I have 6, so I need to multiply to make 6 and add or subtract to make minus 1. So I can do that with a minus 3 and a positive 2. So I have minus 3x plus 2x will give me my minus x. And 3 times 2 is 6. There we go. So x equals 3 and x equals minus 2. Now, when you're working with these distance problems, well, not distance, but when you're working with sides that have a length, it's really good to double check these, that it makes sense. So let's say that x is 3. Well, 3 plus 2, that's fine. That makes a side of 5. 3 times 3 minus 1 gives us 8. That's fine. We can work with that. These are probable sides. What if it was minus 2? Well, if I put that in here, minus 2 plus 2 gives me 0. That's not going to work. I can't have a distance or a length that's 0. So that is not a valid solution. So I can write that. Since x equals minus 2 is not possible, we could write a negative length. X equals 3. You don't have to write your whole life story, just a little bit to show them that you understand. Now that we found the value of x, we can go and fill it in. So that is indeed 5, and that is indeed 8. Find the area of triangle ABC. So that was my CI and my CII. So area equals half AB sine C, which is only possible if I have an included angle, which I do. So I need to use not that side, these ones, my included angle sides, those ones. So I have half A being 5 now, we figured out. B being, well, that's not our B, but our included angle sides is 8. And sine of 60. Sine of 60, another one that you need to know off the top of your head. That is, I can write it up here. So that's right, let's do this. Sine of 60 and cos of 30 is root 3 over 2. Again, if you're not sure of those, go and watch the other video where we talk about that, which is also 3 over 2. So can you see that? You can kind of remember these easily. Sine of 30 is a half, so that means cos of 60 is a half. And the same here, they switch. So root 3 over 2 is our sine of 60. So half, 5, 8, and root 3 over 2. So now we have 2 and 2 is over 4. 5 times 8 is 40. And root 3. 40 and 4, I can simplify. They're both 40 divided by 4 is 10. So 10 root 3. And that's the area of my triangle, all without a calculator. And that was a lovely, how many marks was that question? 14, is that really 14 marks? Can't be. PQ, I've written all over my things, but how much was that? That was 5 and 6, so 11, yeah. That over there, a 14-mark question. That is a really good amount of marks. And this was in the paper 1 SL, so you don't have a calculator, but that wasn't really needed. If you know your special angles, if you've memorized those, that's fine. That's a really nice 14 marks. Anything interesting in the mark scheme? Attempt to use cosine rule. Look at that. How nice are they? Just for attempting to use the cosine rule. There's so much of this in your IB exam. This is why I say try every question. Even if you have no idea how to do it, try it, because all of these attempts are just so useful to getting those marks. And all your substitutions. Substituting correctly. This was another method, which I think is way more complicated, by drawing a perpendicular line. So a lot of students will try and turn a triangle like this into a right angle triangle and then calculate things using SOHCAHTOA. It takes a lot of time. So I wouldn't recommend it, but it is valid. And so remember when we got x equals 3 and x equals -2. If you include that in your final answer, i.e. you write x equals 3 and x equals -2, but you don't say, actually, x equals -2 is not a valid solution, they will not give you this mark for your x equals 3. That happens quite often. So you really need to show that you recognize that it was not possible. So anytime you have distances, speeds, times, anything that can't be negative, just make sure that you've noticed that. Yeah, I think that's all makes sense. Okay. So let's see, I had how many more questions? Maybe I'll do this one actually, because this one, the interesting thing about this one, these are both good questions. I don't know which one I want to show you because we are almost out of time. Let's see. See here we have 2 theta. So that is your hint. Maybe I'll just give you the hint, and then if you want the session notes, you can try these on your own with the mark schemes there. But my hint for you is that when you see a double angle like that, you need to think identities. So see, we have here cos 2 theta or sine 2 theta. You'll need to use one of these identities when you're solving it. And give your answer in this form. I'll do that in different colors so I don't confuse you, but that's very important that you want your answer to be in that form. I'm going to do these. Maybe if someone says they want me to do them, I'll do them. It has been an hour, so I don't know how your attention span is feeling right now, but if you would like me to do them, I'll do them. And this one here, smallest possible perimeter. So when you do this one, you're going to substitute. It's all just substituting into the formulas. And then, okay, I see it. Yes, please. I'll do it. Well done for your the effort you're putting into this. Okay, so let's go for it. We have here a side. These are here. We have included angles, and we need to figure out the exact value of cos theta. So that means we're going to be using the cosine rule, and we've been given all of our values. So let's go and substitute as usual into that one. So we have, and we'll see what happens when we get, because we're not sure maybe like what's going on here, how are we going to find cos theta. Let's just put it onto the formula and we'll see where the land lies. So c squared, let's take all of that out. Just highlight that again to make you aware. So we have A, B, and C already. So let's make that B. In fact, this is the angle side. So I'm going to keep that in terms of my cosine rule with C. It really doesn't matter too much, but I think just can make life easier. Let's go A, B, side C, side A, and side B. And then write our formula. And fill it in. So C was 8 squared. A was 10 squared. B, see how easy it is when you've already written it out. You don't even have to think about it. You just go and fill everything in. A was 10, B was 3, and cos C was 2 theta. Okay. Now let's multiply this out. Still not sure where we're going. We'll probably end up with that and then have to solve. 100 plus 9 minus 60 cos 2 theta. Now we have 109. Just keep simplifying until we get somewhere. 64 minus 109 gives me, I love doing quick maths on a live webinar. So to 70, we have 6, 30, 36 plus 9 gives me 45. 45 equals minus 45, sorry. Minus 60 cos 2 theta. Now I'm going to divide by that minus 60 on this side. So I'm going to have minus 45 divided by minus 60 gives me positive 45 over 60, which is divided by, we can do 15, so 3 over 4. Okay, this is something more manageable. So we have 3 over 4 equals cos 2 theta. So now we need one of our cos 2 theta double angle identities. Which one can we use? We want to figure out, by the way, we want cos theta. So we need one of these that's going to give it to us. Let's do, if we pick that one, we have sine in it. So that's not going to help. Here also has sine, so it's going to be this one. 2 cos squared theta minus 1. So that equals cos 2 squared the cos 2 squared theta, cos theta squared minus 1. No, it was 2. Yeah, that's where I was saying 2 from. 2 cos squared theta minus 1. There we go. Equals 3 over 4. Okay, and now this is something we can figure out. We can figure out cos theta. So let's rearrange. We're going to need to add 1 to the side. So 3 over 4 plus 1. Well, if we put 1 with a denominator of 4, it's 4 over 4 equals 2 cos squared theta. That gives us 7 over 4. Then we need to divide by that 2. So if we divide by 2, that gives us 7 over 8 cos squared theta. Final step, square. So square that side, 7 over 8 cos theta. And let's check where we're up to in this question. Find the exact value of cos theta. Great, I've found the exact value of cos theta. It's root 7 over 8. But they say, give your answer in the form root p over q. So I'm just going to write that over here. Root p over q is how I need to finalize my answer. A bit of a strange final thing that they want. So I'm obviously going to have to do something because that's not in root p over q. And have they said what p and q need to be? Where p and q are positive integers. So they have to be positive. Well, they're both positive, so that's fine. Integers, okay. Well, if I write this like root 7 over root 8 is how I could simplify. That's not in the right form. The top is, that's root p, 7 is a positive integer, but that whole thing would have to be q, and that's not a positive integer. So I need to rearrange. I need to do some algebraic manipulation with this. So root 7, unfortunately, can't simplify. Root 8, however, we can write root 8 as 2 times 4. And root 4, let's go all the way out. I'll do all the steps in case anyone needs a refresher of this. Root 2, root 4, we can separate. Well, root 4 is 2. So this equals root 7 over 2 root 2. Now, if we have a look, Q, nope, that's still not in terms of Q. We need to have no root in here. So we can do something called rationalizing the surd, which is a way to take it out of the denominator. So if I multiply by root 2 over root 2, I'm not changing this number at all because technically that's multiplying by 1. So if I'm multiplying by 1, I'm not changing anything actually, but I'm going to change the form. So root 7 times root 2 gives me root 14. Still fine up there. 14 is a positive integer. Root 2 times root 2. When you have roots multiplied by each other, it cancels out the root. So I have that pre-existing 2 over there, and root 2 times root 2 is 2, which gives me root 14 over 4. There we go. That is now in the right term. So P equals 14 and Q equals 4. There we go. Example of how that might work. That one was 6 marks. I think that was a way more intense question actually than the other one for 14 marks, but there we are. Another interesting way of how they might ask it. They love to ask questions like this. Leave it in the form, and you just have to algebraically manipulate to change it like that. Okay. One more. Let's do A, B, C. Find the smallest possible perimeter. What does that mean? No idea. Well, I do, but I mean, when you're reading the question, you might have no idea what that means, but that's okay, is what I mean to say. Sometimes you don't know where you're going, but you've just got to use the information and see. So let's call that A, B, C, draw a diagram. If they haven't given you a diagram, please draw a diagram. AC equals 12, CB equals 7, and BAC, that's angle A, is 25 degrees. This is a paper 2, so calculator is allowed. All right, what have we been given here? How interesting. We need to find the smallest possible perimeter. Not sure. What might we need to find? So let's see. Let's label my triangle. Let's use another color. Side A, side B, and C. Okay, we have here 2 opposite sides. We could find an angle here, but they're wanting me to find a perimeter. So with a perimeter, we're not going to be able to find, we're not going to need an angle for that, are we? A, B, C. So we have these 2. And we could have those 2. But I think what we need is a side AB, because if we need perimeter, we need a missing side. So there would be our included angle. So I think we're going to need to find side AB, because the angle is not going to help me. I can use the sine rule here and find the angle, but an angle won't help with perimeter. So we're going to need to find AB. Let's have a look at what we have. That's going to be the cosine rule because there's an included angle there. Let's write that in. Let's go with some blue for now. And let's go here. Okay, formula as usual, nothing different here. And we're doing in terms of A. So I'm going to write it in terms of A. A squared equals Not to be confused, I'm going to put a little dot there, otherwise it looks like double C. Yeah. Okay. So we have 7 squared equals b squared. So that's 12 squared plus c squared. We don't know is ab. Squared minus 2b was 12. C was AB. And cos of A was cos of 25. So AB, we're wanting to find that. Let's keep going. That's 49, 144 plus AB squared minus 24 AB cos 25 degrees. So because I have to find AB, I think I'm going to call AB x actually. Because I prefer having my equations in terms of x. Just makes it a bit easier to see. I don't know if anyone else has the same thing. Right. This is looking very much like a quadratic. I have x squared, I have x, and the rest of this is all just my constant. So I'm going to need to do 144 minus 49, which is going to be 90. Wait, and we want to do cos 25 times 24. Let's do that. Cos 25. Simplify that times 24. 21 point, and we need to not round this out. 21.7514. So let's do x squared minus, that was that part, 21.75. I'm just going to write dot, dot, dot for now, so I don't have to keep writing it every time. That was that part, and 144 minus 49 gives us minus 95. No, plus 95. Okay, so, oh, sorry, and there should be an x there. Here we have a quadratic. So with this quadratic, we need to find the values of x. So that makes sense. We want the smallest possible perimeter of ABC. So I'm going to get 2 possible values here. And whichever one is the smallest value is going to be the one that's going to give me the smallest perimeter. So that's equal to 0, by the way. And now we just need to go and solve it. I think I already solved it so that did I? Not to waste time. Unless you want me to show you how to solve it. Because these are some lovely values over here, the way that I would solve it is to just graph it and find the intercept. So this is always good practice anyway. Let's make a new one. New document. Nope. So I would write this as a graph. So x squared minus 21.75. Now you need to take the whole thing, but I'm being lazy because I didn't write down what the whole thing was. Plus 95. It's going to give me a quadratic. Let's make it fit. Menu. No. Well, there we get one of ours. So let me just show you one. But you would keep zooming that out or choose an appropriate axis to find that. And then we go analyze graph, and we want to find a 0. And there is 1, 6.05. So my x1 is 6.05. And the other one I would go and find when I changed the window settings in my graph, but I have it as 15.7. These are my 2 values of x. So now if we want the smallest possible perimeter, that one is 12. that's 7. So to give me the smallest possible perimeter, I'm going to need my AB to be 6.05. And then don't forget to actually find that perimeter. So P for perimeter, 6.05 plus 12 plus 7 was 25.1. That was our smallest possible perimeter. Okay, and that was a lovely 5 marks. So let's have a look at that. We have attempt to use cosine rule. Love that for us, just an attempt. At least one correct value for AB is a mark, so that's also very nice. So if you didn't get both, you'd have those 2 values. And then using your smaller value to find the perimeter. So a different kind of way of them asking the question that might seem initially confusing, or where are you going with it? But just think about the formulas. Even if you don't know how to answer it, just start substituting into a formula. So even if we weren't sure with this one, we substitute in, and then you end up seeing, oh, there's AB. So that's what I need to figure out, that missing side. Okay. I hope it's not stuck. My screen is showing that I'm still on the calculator. There we go. Okay, so tips that I think that you should really do every time is to draw and label the triangle, like I was saying. If they are giving you different labels, then relabel it with your ABC. It just really, really helps, and then you don't have to think about it. And always write the formula first, and store values or write out full values or use answers so that you don't round too early in the question. You should only be rounding to 3 significant figures at the end of the question, not during. So make sure you use the whole thing until you've got to that final answer. As usual, notes you can find on Learn on these and some different questions, and there will be a homework assignment for session 9 posted over there. All right, any questions at all? Sorry, it's been a little bit long. Anything at all? Hopefully that was helpful and you learned something new today. Just keep in mind with those kind of questions, the way to do sine rule and cosine rule is quite straightforward because it's just substituting into a formula. But when it's in the exam, they often add a couple of extra layers that make it maybe seem confusing, but it's not. It's just some like extra fluff that you have to work out in order to be able to go ahead with the question. Awesome. Glad to hear it. Thank you. All right, then. We will have 4 more sessions coming up this weekend. So keep an eye on the calendar, and the exam strategy session we've moved to just before the exam. So that's kind of like a last thing. So at the moment, we just keep doing the topics and then we'll get there. So thank you very much for joining and have a lovely evening. Goodbye.